Good afternoon, everyone. On behalf of the Department of Computer Science and Engineering and our institute, Sri Vishnu Engineering College for Women, Bhimbaram, and we welcome all the participants, including our resource person, Dr. T.S. Pradeep Kumar Garu, Professor in the Department of Computer Science and Engineering at VIT Chennai, to this webinar. And I am very thankful to him, despite of his busy schedule, he is able to allocate time for us. Before getting into the webinar, I wish to introduce Dr. T.S. Pradeep Kumar Garu. And Dr. T.S. Pradeep Kumar is a professor from School of Computer Science and Engineering from VIT Chennai campus. He is an IEEE senior member and he has delivered more than 200 workshops on sensor networks, Internet of Things, cyber physical systems, software-defined networking, wireless networks, and network simulations, e-learning, learning management systems, etc. And he has deployed and maintaining module learning management systems for VIT Chennai since 2010, which can handle more than 15,000 users. And his research interests include power modeling of Internet of Things and sensor networks, cyber physical systems, e-learning methodologies for computer science education, and he shares his knowledge to students, scholars, and faculty members through his YouTube channel named Engineering Clinic. You can access this by YouTube TS Pradeep Kumar channel also, and through his website www.nsnam.com. And it's a privilege to have you here, sir. And all the audience and myself and all the faculty members are waiting to listen to your talk.
Thank you very much, sir.
Please proceed, sir. Pradeep Kumar.
Yes.
Thank you very much.
Let me share my screen.
Please.
Is it visible, sir?
Yes, sir. Your screen is visible, please.
Okay. So good afternoon and good evening, friends. So today's topic is on research in real-time societal applications and how to carry out the procedure for this kind of researches. So this is what the topic for the day. And since many of you, some of you were students, some of you were already PhD holders. So what I will be doing is I will be taking you some societal applications. What are the things available in the world, and how do we collect the data set, and how do we conduct some research on it. And I have a case study that what we have done. So what we have done along with a set of students that I will be showcasing you, and what are the different things that we have done, and finally what was the outcome also I will be showing you. So this way I will take this entire session in this way. Okay, so before that, before going to this presentation, I want to give you one website called as aqicn.org. So AQICN is air quality index. AQI is air quality index. This is a Chinese website, but they have deployed sensors across the world, not only in China, across the world. So one good example is now I am in Coimbatore. So I am not in Chennai. I came for another board of studies meeting here. So right away here I am just checking it now. So in Coimbatore, where I stay now. So not where I stay. In the Coimbatore map, they have some multiple locations. They have this air quality measurements they calculate. You can see here, this is the air quality measurement at various locations in Coimbatore. So somewhere, just a minute. So here, this is where it is Coimbatore. It is simply 9. The value is 9. Okay. So the location is air pollution in Sidco, Kurichi, Coimbatore. So real-time air quality index visual map. So let me go in Chennai. In case if you're trying for your own location, you can try that as well. So I'm just trying in Chennai. So Chennai at one location, it is unhealthy. So it is Bangalore. So let me go with Chennai. Okay, so I'll just come here at the end of this. So it will be showing you what means the air quality index. So 0 to 50, it is good air pollution level. 0 to 50, it is in green color. If it is 51 to 100, it's a moderate thing. 101 to 150, unhealthy for sensitive groups. 151 to 200, very unhealthy. And 200 to 300, very unhealthy. And 300 plus is hazardous. Okay. So this is the air quality index happening in and around that particular place. Here we have one thing called as PM 2.5. So PM 2.5 is particle matter 2.5. So this is one of the thing which is very dangerous to the lungs. So once it enter your lungs, it can able to stop the functioning of lungs as well. So that kind of it's in micro granules only. So the micro granules can able to do the very biggest harm to human lives. Okay, so that is what the beauty of this air quality index. Now I will go in Chennai. So Chennai, there is US consulate there, but it is showing only Bangalore just. I'll just take Chennai somewhere directly from the map. So in Chennai, there are 4 locations you can see here. One location is Arumpakkam, it is 138 unhealthy. There is some location in Kodungayur, it is 65, it seems to be moderate. In one location, it is Rayapuram, it is in the city, 104, and 132 near the US consulate, it is 132 unhealthy, and 98 somewhere in Manali, where there is only industrial hub, there it is 98. Because it is a Saturday, many companies may not be working. So if you see these temperature, air quality parameters during the morning, night, 10 o'clock on a working day, this might go up to 250, something like that. Now the same thing I will show it in Delhi. So you can see this is Delhi. Mostly you can see that 144, 161. So this season is of rainy season. So they have the better air quality index. But during the in the another 3-4 months down the time, so air quality index in Delhi might be crossing 600 plus. So 300 plus is hazardous. So think of 600 plus. So during those time, the Delhi government gives holidays to the students. They want to stay inside the house. They have to stay indoors. They ask not to come outside. So that kind of hazardous things will be there in Delhi during the month of November, December. So because of the fumes comes from Punjab, and people will just what they do after the harvesting is done, so wheat harvesting is done, they simply burn the crops. So the crops burning, the smokes will be coming into Noida, Gurgaon, and Delhi, and complete Delhi will be going beyond 600 plus and sometimes 800 plus also, which is very, very, very hazardous and dangerous. So if you inhale that for half an hour or more than half an hour, you will be having a serious lung infection. So it might lead to lung cancer as well. So that kind of dangerous thing is there. This is one of the very potential problem where we can see a real-time societal problem that anyone can able to do a research on this topic. So just to showcase you how this air quality index is working. So in case, since your college is in Bhimavaram, let me try it here. Bhimavaram. Yeah, so there was no sensor recorded at Bhimavaram. So Amaravati. So Secretariat Amaravati. So somewhere in Andhra Pradesh, it is shows only 22. So Amaravati it's showing at 22 only. So very good value there because it is good air quality index at Amaravati. So many places we have this kind of air quality index is very dangerous. That thing we can able to see. Even can see Hyderabad also. There is Hyderabad also. It is can see many locations in Hyderabad. 46, 30, 61, 68. So mostly they are good because maybe across India the climate seems to be good, I suppose, and even Kolkata. Okay. So Kolkata, I can see some locations that is 122, which is unhealthy for sensitive groups. Okay. So this is one kind of a real problem, societal problem that anyone can address upon it. So okay, now let me go into my topic here. So what the overview for the today's session will be, these four things we will see. Real-time societal applications, what are the different applications that we can work upon? The challenges, what do we face? And the requirements, what are the things is really needed? And case study. So case study is what we have done on a real societal problem where everything is challenging for us, but still we could able to accomplish it. So these are the different things that we will be seeing for today's session. So now there is a quote: when great societal need meets appropriate scalable solution, there is much societal and economic benefit to be gained. So obviously there will be some gaining in the social, and the economic benefit can be gained if we have a scalable solution for any societal needs. So that's what this statement says. Okay. So some of the real-time societal applications. So as I pointed out first, the major one being air pollution. So air pollution is generally not only caused by one parameter, it caused by 5 parameters. So you can see particle matter PM 2.5, nitrous oxide, carbon monoxide, carbon dioxide, and hydrocarbons. Okay, so these are the 5 different gases it was producing. So as you all know that the diesel engines, so any vehicle with the diesel engines, they emit more carbon monoxide than a petrol vehicles, than a electric vehicle. So electric vehicle it will not do, but electric vehicle have some problem of the battery. After the battery is been reused, we cannot reuse the battery. We have to throw it away. How to throw it away? That's a major challenge on a battery. So as of now, the world doesn't bother about that. But in future, that will also be a very big problem for. I mean, putting the battery. What is the problem of recycling a battery? If recycling is not there, how do we safely discard the batteries? So that kind of issue will come. But in when see petrol and diesel engines, diesel engines emits more carbon monoxide than a petrol engine. So that's why in many places they are simply stopping the diesel vehicles. So air pollution is first one. So the majority of the 5 gases that is for this air pollution is these 5 gases: PM 2.5, NOx, hydrocarbons, carbon monoxide, carbon dioxide. These are the 5 gases. Next thing is actually this is for achieving GPUs and FPGA. This is for achieving requirements. And water management. Next thing is the water management. So this is again one of the real world problem for water management. Irrigation, we need water for irrigation, many purposes, drinking, and quality water for drinking, and for agriculture, and for many things, even for production, manufacturing. So everywhere we need water. So how that water will be managed? So how efficiently the water will be managed? So that is again one of the greatest real world societal problems. Then cloud burst. So this is what one case study that we have done on our research, cloud burst. So recently you might have seen a cloud burst in Kedarnath. So somewhere in the Uttarakhand, we know that there is a Kedarnath, there is a temple. So 2015 there was a cloud burst. Because of that, many people have died. And even in 2022, in the month of May, there was a cloud burst. But of course, many lives were not the. I mean, only 2 or 3 have been dead, but still it was a cloud burst. But immediately the government have evacuated the people, those who are stranded over there. So this is one of the greatest challenge of a real world societal problem. Next thing is health. So health, as you know that health in 1970s, 1980s, 2000s, 2010, 2020s, it's different. 2020 now, we have many health things there, and even many diseases also, new diseases have been introduced, and new kind of medical practices also been involved. So always health is one of a primary concern for anyone. So be it a small disease or to a bigger disease. So how we can able to handle the health related research. Then assisted transportation. So this is one kind of transportation that anyone is needing now. So assisted transportation means, so we use Ola, Uber, and I mean automated cars like that. So assisted transportation means whenever you want to go to reach any place, how your car assists you in reaching the particular place safely. So that is we call the assisted transportation. So that will be very soon will become a reality. So car to car communication will be there, and car to infrastructure communication will be there. So we call it as V2V, V2X, V2I, like that we can say V2X. So that means vehicle to anything communication, or X to X, X to V, anything to vehicle communication also. So that the vehicle can interact with any other vehicles on the road, as well as it can interact with the roadside units or the traffic signals. So that kind of assisted transportation will also be one of a real world problem. So data collection may not be, data set may not be available for these things, but we have to create a data set for future use. So that one kind of a real world problem. Then social credit algorithms. So this is one thing, we have an Aadhaar card now. So everyone have an Aadhaar card in India now. So even a newborn child also will be getting an Aadhaar card. So people are getting it. PAN number was there over a period of time, but PAN was not so automated. But now it's an automated. So if you have an Aadhaar card, if you go use the Aadhaar card anywhere, it automatically links to your PAN card as well. So in that case, what happens? You are being monitored. So whenever a bank is giving you any loans, whenever somebody wanted to give you money, they could able to know about you. How good are you? Are you good in repaying the financial instruments, or how good are you in repaying the money? So that kind of social credit algorithms that you can think of in a real world societal problem. So again, if you develop an algorithm for this, many banks, many financial instruments, they will be trying to gather these kind of things, and they want to deploy on their systems. So that kind of real world problem also is there. Then VR and AR. So of course, you know that this Pokemon was there, which is one of the very greatest augmented reality application. So where in the real world map, you can able to pick out some characters, and once as and when you pick the characters, you'll be getting some rewards or something. And many people were doing, and many things were happened during when Pokemon was introduced in the beginning, but later on it became a de facto. Okay, so VR and AR also one kind of real world problem is there. So real world societal problem means now how you can teach, through augmented reality. So let's say now I'm doing something online. So had I have some augmented reality application, so directly in front of your computers, I can show you an augmented reality application so that you can better understand what I was, instead of seeing my slides, you can able to really feel the application that what I'm demonstrating. So that kind of augmented reality for learning, augmented reality for research. So those things also will be having a greater scope in the days to come. Then chatbots based on AI. So chatbots. So actually, this is one of the most wanted thing in any website, any portal applications, any mobile apps. You have these chatbots. So be it a travel partner, be when you purchase a mobile phone online, or whenever any website wanted to get feedback from you based on their applications. So what do you do? What they can do is in the right hand side, a small pop-up window will appear. So that pop-up window will say that it is a bot. Okay. So maybe I will just show you again one more here. Maybe one place where we have Purvika mobile. I don't know whether it is there. I will show you that. So this is a mobile phone online store. Okay, so you can browse through something. So let me click computers and the thing. See, automatically right hand side there's a WhatsApp number there. So okay, anyway, it's WhatsApp. So somewhere in the bottom right, you'll be getting a pop-up menu. You'll be getting a pop-up menu that so from where are you browsing? So can we help you? Something like that. It will be showing you. So maybe I'll just go to one more page. Okay, it's not appearing, but somewhere in Reliance Digital. So in the bottom right, you can see that there will be a pop-up menu will appear. Anyway, it's not appearing here. So maybe so this is kind of these things we call it as a chatbot. So chatbot means some real artificial intelligence engine will be talking to you, saying that what you want, what kind of help you can you want from us, like that. So many places here we have a travel platform like Make My Trip, Booking.com. Then colleges, if you take VAT, SRM, universities you can take. So and you can have medical chatbots. So what do they do is, let's say in a travel chatbot, you just come to one Make My Trip. Make My Trip automatically gives you a pop-up menu saying that how much money do you have in your hand. So you are telling the 20,000 rupees, I want to travel in India somewhere, or 20,000 rupees, all inclusive, I want to travel to any foreign country. Then the travel chatbot will suggest you, for this 20,000, you can travel to Malaysia for 3 days. The hotel stay is this much, the flight ticket is this much, the visa process is this much, all these things, and it will be suggesting you some options. So these countries you can go with 20,000 rupees for 2 peoples. It will suggest you. So in that case, you can have a plan of it. So everything based on artificial intelligence. There is no manual thing involved. Everything based on AI. So this is again one of a real world societal problem that you can able to address upon. So actually for these things, still there is no mature solution available, but it's in process. Okay. Now when you say smart materials and devices, so smart materials is the smart sensors. So how really the smart materials and devices that can help you in achieving any societal benefits, security protection for various systems. Then voice spam prevention. So nowadays we are getting voice spam prevention. So somebody talk to you, they asking for loans and something. So that kind of prevention is, see, whatever you do, somebody will be talking to us, somebody will be um, always asking about, do you want this loan, do you want this credit card, we will be offering you freely, and we will be giving you so 2 tickets for your family, please come and collect at this location. Some kind of these things are there, but how we can able to prevent it. And technology for humanity. So generally, if you say in a generalized term, technology for humanity means through machine learning or deep learning, how can we achieve humanity through technology? So these are the different societal problems that what I can think of. I have just put it down here, and there are many other things in and around you. You can able to find out problems. Okay. So one example is since it is in Bhimavaram. So last time when I came to Bhimavaram, I could see that there was a greater potential available for prawn cultivation in Bhimavaram. So Bhimavaram, the entire place is based on there are sea shores around. So the prawn cultivation is happening in mass scale, in the greater scale in the entire town. So what they can do is they can use harvesting prawns. One thing is prawn cultivation. So they can able to get prawns, and in prawns there is some white patch disease will be coming up. So through image processing algorithm, they can use they can have solving the identification of the white patch prawns, and they can be discarding it. So that kind of work they can able to do. So likewise, in nearby your places, you can able to find out there are many societal problems available in the world to solve it. Okay. So even when you ask your parents about what if they are feeling something in cooking, when they cook, had there is a device like this, I would be very happy. So something like that. If you ask your parents, they'll be telling you what kind of problems they'll be facing. For that, we can able to solve a solution. We can able to give a solution. So this is where the societal problems can be handled very easily through technology. Okay. So what are the some of these things what I came across my mind, I have just put it down here. But there are many society related problems are there in the thing. So you can help the farmers on agriculture. You can help if you are near to the shore, you have coconut trees. So in the coconut trees, palm trees. So how coconut trees and palm trees can be cultivated? So how we can able to use tender coconuts? How can you convert into coconut? So how can you get a greater yield? So those things we can able to do paddy. So likewise, there are many things we can able to do on a larger scale that can help farmers, that can help peoples across the world. So this is some of the examples of societal issues. Now, what are the challenges for this problem? So challenges means collecting data from a global data set needs huge bandwidth. So for these problems to solve, we need huge bandwidth. The bandwidth means our computing resources may not be sufficient enough to handle all these things. Getting some. So collecting data from global data set needs huge bandwidth. So that means we need to have our system should have huge bandwidth to be collected. Increases with increase in the number of wearable sensors. So many, suppose I want to use a number of wearable sensors to be very huge. In that case, the bandwidth also will be increasing very huge. So we need huge, heavy bandwidth for that. And big data, higher bandwidth and cloud processing. So of course, we need to have process big data in terabytes and higher bandwidth, more than 1 gigabits per second, and cloud processing. Most of the data should be in the cloud processing. So one example you can say the time taken to train a 4 GB data with 1 Gbps speed takes 30 seconds. Just see the number there, 4 GB data with 1 Gbps speed. That means your bandwidth is 1 Gbps. Okay. So mostly in the house internet we get 100 Mbps and 150 Mbps. So 1 Gbps is something 6 times or 7 times faster than what we use in the internet in our house. So 1 Gbps speed, 4 GB data, it takes 30 seconds. Whereas the 40 terabytes takes almost 2 days for a 1 Gbps. Suppose if we use 10 Mbps bandwidth, it takes around 180 days, almost 6 months to train the complete 40 terabytes of data. Suppose I want to do something on a air quality index for the entire country. Let's say if you want to take India for the last 2 years, so 2021 and 2022, 1.5 years, I want to do the air quality index. I want to do the calculation. I want to download the data and process it. It may take at least 2 to 3 months to process train the complete data. So that means I need to use that much bandwidth. I need to use such a huge data. It's a big data, what we call. So these are the main challenges for handling such kind of real world problems. See, as long as if you do for your small family, a small farm field, it's fine. But when you're thinking about a city traffic, when you're thinking about a country, when you're thinking about a state, it becomes very huge, very huge. So you need heavy computing resources. So what are the resources you need? So you need a storage of 100 terabytes plus. So that means 100 TB plus. So I'm just telling one example is the air quality index. So air pollution. So we need 100 terabytes of data. We need more than the storage we need. Then higher bandwidth collection. So that means more than 1 gigabits per second data you need to process. So 10 gigabits per second. So 10 gigabits second is not possible. Not possible means only some higher end they will be using it, but we need to go with at least 1 gigabits per second speed we should have. Then social media handle like Twitter to be harvested. That means sometimes what happens is we have to read from the Twitter feeds. So again, for processing Twitter feeds, we need many heavy computational things we need. Then high-level languages with the toolboxes like MATLAB, Scilab, etc. So we need to go for some software that have some tool sets to process our algorithm. So in that case, we need to go for MATLAB, Scilab, etc. Then algorithms to handle non-linear, non-parametric data sets, etc. So sometimes what happens is whenever you download a data set, usually the data set will be non-linear and non-parametric. So in that case, so far there are many algorithms available to solve the linear data set and parametric data sets. But if the data is non-linear and non-parametric, so then it becomes complex. So you need to know to solve an algorithm for solving these kind of data sets. Then use of multiple CPUs and GPUs. So again, this another thing is CPUs and GPUs. So nowadays we mainly use CPUs for all the processing, but at times we need GPUs also. So GPUs will be in thousands of number of cores so that the GPUs can be bombarded with some powers. Okay. Then automate workflow and schedule tasks at precise times. So that means automate workflow means so everything should not be manually triggered. We need to automate all the workflow processing. So in that case, these are the platform and requirements for solving such kind of problems. So I have just taken one problem is air pollution. We need this kind of thing. So for each and every societal problem, you need to identify the challenges and you need to identify the requirements for it. So once having set all these things, then you can go for the next step is data set. So since it is a real world problem, so we need to rely upon data sets. So data set means somebody gives a data set, I download the data set and I can start using these data sets. Okay. Now one thing is, so data sets, how do you collect the data sets? So one place is data.gov.in. So this is one location. Kaggle, there's one place. Then IEEE data port and Google data studio. So these are all some locations where you can get the free data set. Some free data set you will be getting, and some data set will be some with the logins with authentication. They will give some data sets. So likewise, we can get. So if you want Indianized data, you can go with the government data sets. So data.gov.in. Kaggle is data set plus competition. So it's a kind of a coding competition something. IEEE data port. So IEEE members, IEEE institutions, the institutions share the data set to IEEE, so that IEEE facilitates those data to other IEEE members. Okay, so you can use that. And Google Data Studio, they also give the data set across the world data. You can able to get it. And there are many other places where you can get the data set. So sometimes you can generate it also. You can generate data sets. This is also possible in many occasions, but this is again advanced users can able to go for the data set. But many of the societal problems with the data set, your approach will be some more, you are nearing to the solution for it, because already somebody working on the data sets, you download the data set and running some algorithms and find out how we can able to solve a problem for those issues. Okay, so this is where the data set comes to this. Okay, now one example is this case study. What we can see, the case study is a cloud burst. Okay, so this is what we have done. So actually this work we have done 3 years ago, along with me, the 2 other faculty members, with some 2-3 students. So we have planned for a work. Actually, one of the students was from Uttar Pradesh. So he was trying to solve a problem on cloud burst. So then this student have went to Uttarakhand a couple of times, particularly to Kedarnath, because in India we have seen a major devastation because of a cloud burst is happened in Kedarnath. The recent thing is Kedarnath in 2015. So many people have died, and many many places have been relocated, dislocated. So many things have happened. So that is a major thing that we have experienced in India recently. But across the world, cloud burst is happening somewhere, one way or other. It's happening across the world. But in India, what we experienced in 2015 and 2022 also, we had similar kind of thing, but not that much devastation. Okay, so this we have done it 3 years ago. Okay, now you can see that how the cloud burst occurs here. So you can see in the right hand side we have a small diagram there. So temperature below 0°, glacial water droplet crystallizes over cloud, further dense cloud descends. So generally it happens at when the temperature is below 0°, and here aerosol high temperature and solar flux. So because of this reason, there is a cloud burst at this location. So cloud burst means what happens in suddenly within 1 hour, there will be heavy to very heavy rain. So that kind of that is called as cloud burst. So it is like opening a dam from the clouds. A dam of water opening from the cloud. Just think of how devastation it will be. That is called as a cloud burst. So I have given an explanation there. A cloud burst is an extreme amount of precipitation in a short period of time. When the rainfall rate is equal to or greater than 100 millimeters per hour, it is categorized as a cloud burst. See, actually, 2016 or 17 in Chennai, in one location, it was 49 millimeters, I think. Yeah, not 14. Yeah, it's a 49 centimeter over a period of 1 week. But here it is saying that in 1 hour, 100 millimeters. That means 10 centimeters in 1 hour. So which is that means almost half of the city will be in water. So that is what it means. The rate of occurrence of cloud bursts are increasing, which emphasizes the need for a prediction model. So cloud bursts are very new to India, particularly till 2015 we experienced it. But before that, cloud burst was a dream. Dream means we never know that there's a cloud burst. But nowadays, after 2015, in some corner of the world, the cloud burst is happening. Every year, there is a cloud burst at some location, it is happening. Okay, so there should be a prediction model. So that's why we were trying to work on it. But the real challenge what we have is we don't have a data set, or the cloud bursts are rare occurrences. So we have a problem of data set. So what we did is to create a model capable of predicting cloud bursts based on the importance of factors. Markov chain model is used to collect the weather data for the previous or last 7 days. So what we collected is the last 7 days data we have taken, the rain data we have taken. This model forecasts rainfall intensity and in turn cloud burst. So intensity of the rain and in turn the cloud burst. So nowcasting is this we named it as nowcasting, a method to predict rainfall in the next 0 to 6 hours based on the current weather and the forecast. So within the next 0 to 6 hours, within the next 6 hours, what could be the amount of rain we can get it? What could be the intensity? One good example is let's say in Chennai, it is start to rain. So obviously we can able to find out within the next 20-25 minutes, we can able to find out how much amount of rain we might be getting in the next 6 hours. So that if it is a college or university, in the school, if they want to declare certain holidays or they want to declare leave for the students so that they can go early to their homes, such kind of decisions the government can take. So that's why this method is called as a nowcasting. This is what the objective we planned. Okay. So cloudburst, the challenges. So what are the challenges in this cloudburst? We experienced it. Cloudburst is a rare phenomenon and might not occurred in the same location multiple times. Okay. Now at the time of writing this thing, the cloudburst was not happening in Kedarnath second time, but in the month of May, actually in the month of March, I presented this in a conference in the cloudburst in a conference, and even I got a best paper award also for this work. But in the month of March, we didn't expect that the Kedarnath again it happened, but in the month of May it happened. So second time in the same location, after almost 7 years later, it happened cloudburst, but not that much severe, but still it's a cloudburst. So the data sets are of usually limited to 1 or 2 days of cloudburst data sets. So mostly predominantly in the entire world, when we collected the data set, they were available either 1 day data set or 2 day data set. That's all, not beyond that. Also, cloudbursts occur in various seasons and at different locations every time. So various season means in India, it happens in month of May. In US, Canada, it happens in the month of September, October. So likewise, every corner of the world at some different seasons, some different locations, it happens. Model with high accuracy is a challenge. So high accuracy, we could not predict with the good accuracy, but we can able to suggest something. So that is what the challenge what we encounter. So issues with the existing literature. So when we collected the literature survey, there was no literature on this predominantly, but then and there we got some work. So many of these literature were too complex and expensive to deploy the system. So some people were using very complex systems like very bigger turbines kind of thing, then they deployed it. So without funding, we could not do that. And some of those are very inaccurate. Geolocation dependent issue. So some of them are suggesting to use this particular location that we cannot go for. Prediction of cloudburst in a wrong location. So sometimes what happens, cloudburst might have happened at one location. To the somewhere other location, they might have taken the data set. So that prediction also and lack of precision. Lack of precision means the closeness of the data is not that much accurate. So that is what the lack of precision. So these were the existing literature what we encountered. So what we did is we have collected a data set called as Prism. That's a data set available for climate group data set. So there are two data available. One is current day and the previous day. So today and yesterday. So this data was available. And we have done with the two different things, incremental weight and constant weights for each and every day. Okay, so that's where we were using, and we use Markov chain. Markov chain means, as you know, that one day one output is fed to other input, like that it will be going as a chain. So one output fed to next output fed to next, like that it will go. Okay. So now this is the data set what we have. So you can see that we collected the data set of 2000. So almost 22 years ago, this data set was there. So you can see precipitation in millimeter and temperature in degrees and T mean temperature and maximum. So we have mean maximum temperature, mean dew point. So these things we have taken minimum vapor pressure deficit, maximum vapor pressure deficit. So these things we have just taken the Prism sample data set. Okay. Now we have mentioned we have tested all the models because data set is available, machine learning models also available. So we wanted to test it on all the algorithms what we encountered in machine learning so far. So we tried with the k nearest neighbors. We tried with support vector machines. Then we tried with the single layer perceptron. We tried with the multi-layer perceptron. So both we tried. So we have a hidden layer like this. So single layer and multi-layer perceptron we tried both. So that some hidden layers are there in between, and we could able to get a better output on this. And how we assign constant weights, you can see that day 7, day 6, day 5, day 4, day 3, day 2, day 1. So totally we have 7 days, and we have the machine learning model. And for predicting X8, the equation is used. So how we use the equation is x7 into 0.8 plus x6 into divided by 6 into 0.2. So this is how the way we use the constant weight. So we have used two weights, incremental and constant weight. This is the constant weight. For predicting a Monday, how do we predict this? This is how the way we for predicting a Monday. So for Monday, we take the data of Sunday. So today and yesterday, Sunday data, we will be using it. So this is how the way the constant weight we use in the Prism data set. Now, for predicting a Monday, so you can see how we use it. So it's a weight 0.7 weight divided by 2. So this is an incremental weight divided by, sorry, I put constant weight here. It is incremental weight. Weight by 4, weight by 8, weight by 16, weight by 32. And this is how the way I can predict a Monday. So constant and the incremental weights. So this we used for prediction. So data set division, we have divided the data set into 3 classes. So class 3, class 4, and class 5. So class 3, 0 to 10 mm, 10 mm to 20 mm, more than 20 mm. So this is what the class 3. Class 4 is 0 to 8, 8 to 15, 15 to 30, and more than 30 millimeter of rain. Class 5, we have 5 classes. So 0, 0 to 5, 5 to 12, 12 to 20, and more than 20. So totally we have 5 classes. So 3 classes we have 0 to 10, 10 mm, 20 mm, and class 4 we have 4 data sets, 4 values 0 to 8 mm, then 8 to 15, 15 to 30, and more than 30. So but class 5 was too optimal. So because we are segregating the rain data into 5 different segments. So that's why we used for class 5 data sets. Okay. Now when we see that the accuracy using that day data and using the previous day data. So when for the particular day data, we got the highest value was 68.5 is a multi-layer perceptron. Somewhere here we got the best data set. And next thing is scalable vector machine. So where we have 68.4 for the particular day data set. But the previous day data set, we have 60.2 and again SVM. So multi-layer perceptron outperforms other models in this accuracy. But still the accuracy is 68 or 70% only. But still it is not 90% accuracy. We cannot say the 90% because the cloud bus data is we have taken from some different region of the year 2000. Okay, so that's why the cloud, the cloud bus is not happening everywhere, every year or every time. But once it happened, the data set was available. The only this thing we have just taken. That's why this accuracy is only 70% maximum. So, and this is how the way the data sets you can see here. And again, a multi-layer perceptron play a major role, and SVM and logistic regression also did a great role on this. Logistic regression, you can see the last but one logistic regression on the particular day data. And again, for the previous day data, you can see here MLP did well, the orange color. And next thing is SVM, and again logistic regression and KNN also. So these things did really well on this accuracy. So the accuracy is again somewhere stopped at 70%. Now ML models here incremental weights and constant weight. So constant weight in blue color, incremental weight in orange color. So again MLP, you can see MLP outperform the other models for this data set is somewhere around 63-64%. So then we have SVM that also somewhere around 60%. So maximum accuracy what we is only between 60 to 70%. Okay. So the linear regression was the smallest one that have an accuracy of just 20%. Okay. So linear regression, we could not able to predict anything on that because it's completely only 20%. But other models really did well. The deep learning models really did well. So this is what we have identified this Prism. But for the cloud bus, other than Prism, we could not get any data set. We could not get any data set. So now we are in the process of creating a data set. So how do we create this? So you can see here, this is the outcome. After the project, after the work we have done, we have deployed, this is our campus, VIT Chennai campus. Here, this is in the health center. So in the health center, in the top of the health center building, we deployed one rain gauge. You can see the black color thing with the wire connected there. It is a rain gauge. Rain gauge means whenever there is a rain, it will be telling you how much amount of rain is been there over a period of time. So, but it is not a real time. Real time, as and when the rain is there, it is not like that. So once in a particular day when it rains, then at the end of the day, we can able to collect some data on that. So we are creating a data set since last 1.5 years. 1.5 years back, we have just deployed this. So whenever there is a rain in the next day, we will go and just record those values and we'll create a data set. So whenever it is raining. So whenever there is no rain, we don't bother it. But whenever there is a rain, we just do that. So this is the outcome we are just predicting. And this rain gauge, it can help us in cloud burst also. But of course, in Chennai, in 2017 or 16, we had that not a cloud burst. It is a very heavy rainfall. We could not say a cloud burst, but it slowly rained over a period of 2-3 days continuously without stopping. So we cannot say that cloud burst. Cloud burst means within 1 hour there could be devastation of rain, heavy to heavy rain. It can reach up to 10 centimeters. So that is what we call as a cloud burst. But heavy rains. So this rain gauge can able to go for very heavy rain. Okay. So in the conclusion here is a rainfall intensity has been used as a metric to forecast cloud burst. So a rainfall intensity has been used. So rainfall intensity means how much amount of rain is there. So that rainfall intensity it's as a metric. Comparisons of various machine learning models applied on a weather data set to predict the rainfall intensity have been carried out. Okay, so that is on carried out. The comparison of various ML models like KNN, SVM, MLP, single layer perceptron, linear regression, logistic regression, all the models. The proposed model perform well and show significant improvements when compared to the existing model. If the rainfall intensity is greater than 100 mm, the model gives out a warning of a possible cloud burst. So if the rainfall is more than 100 mm, obviously the models will give a possible cloud burst. This can further be improved to predict the intensity of rainfall and cloud burst for more days in advance. For handling real-time data feeds, Apache Kafka can be incorporated, which would provide an unified platform with a high throughput and low latency. So in case if we want to use it, we can able to use the Apache Kafka for real-time data for a unified platform for handling all this information. Okay, so this is what one of a real-time problem that we have just solved in the days when we were thinking of it. So this is what one of a case study what we were doing. These are the some of the references. Okay, so now what I will be doing is, so I already told you this. So how to achieve this? So how to do a research on such real-time societal applications. Okay. So I will give you some of the suggestions. So how do we start this? So many of the time these work have been started by our students. So the students have brought this idea and then we were doing it. But sometimes if the student doesn't bring the idea, so then we are in a position to handle this thing. So first thing is identify a problem faced by the peoples at your working place or your house or with your neighbors. Okay, so this is where your first identification of the problem. So that means identify the problems faced by the peoples at your working place or your house or at your or with your neighbors. So this is the first thing that you can able to use it. Your house means your house with your neighbors or near or the place where you live. So this is the first thing that you can think of whenever you just wanted to have it. Okay. Number two is, are there any solutions? Are there any solutions available already? Are there any solutions available already? So this is the next one you need to think. Then collect literature survey of those problems or issues. So collect literature survey of those problems or issues who have already solved, which already been solved by other scientists across the world. So this is the next thing you need to do. Okay. Now, number 4 is the challenges. If you want to accomplish it, if you want to provide a solution. So identify the challenges if you want to provide a solution to those problems. Okay. Number thing is system specification, requirements, and resources needed to solve the problem. Okay. So this thing you can able to think of what is system specification we need, requirements, and resources needed to solve the problem. Okay. So by this time, when you come to this point number 5, that means you are completely identified or you can completely understood the problem well. And only thing is, it is only the implementation difficulties that only you need to take care of it. Okay. Okay. Now next thing is identify the domain to solve the problem. So domain means what are the domains is it be image processing, and then machine learning, the neural networks, or otherwise we can call deep learning. So then you need cloud computing. Then you need big data. So then you need AI, then Internet of Things. Then you need blockchains. So then you need metaverse, AR, VR. Okay. So these things. Okay. So number 7 is system requirements, CPU, GPU requirements, CPU and GPU requirements. CPU and the GPU requirements. Okay. So number 8 is data sets. So check for the data sets. So check for the data sets available in the above websites. So these are the different data sets that you can think of finding the data set at these locations. Actually, here also it started raining. So similar to our area cloud burst, but I think heavy rain. Hope I'm audible, right, sir?
Yes, sir, you're audible.
Yes, sir, you are. Yes, sir, you are audible.
Yes. Yeah, here the power supply is gone, so anyway, that's why. Fine. Okay, so check for the data sets available in the above website, and there are many data sets providers are there in the market. So you can check where the data set is completely available. So you can use those data sets, and then you can start working on those algorithms. Okay. Now, whenever if you use machine learning algorithms, so ML is the one can handle many of the data sets. If the data set is limited means, let's say less than 1 lakh records. Else go with deep learning or neural networks model. You can go with it. So ML is the one can handle many of the data sets. So if your data set is of 40,000 lines or up to 1 lakh lines, you can comfortably run with a machine learning algorithm. So machine learning algorithm means you can go with classification, you can go with supervised learning, unsupervised learning. So like that you can go for. Suppose if it crosses 1 lakh and if your data set is 3 lakh, 4 lakh, 5 lakhs, like that, if the data set is very huge, then no longer you go with the machine learning. You have to go with the deep learning model. So that neural networks can able to handle multiple hidden layers, so that the processing time will be limited. Okay. So generally we call those things generally Google point of view, we call that as tensors. So TensorFlow models. So we can use this in the models. Okay, so we can use TensorFlow models for these things. So then afterward, validate it. So validate against the validate the prediction. Sorry, validate the prediction against other predictions from the literature. So this way, you can able to the prediction. You might have done a prediction, and already there will be some predictions will be suggested by some other researchers in the same data set or some different data set. Then you can able to validate your results along with their results. In what way your performance is better than their performance, and in how that can. And finally, the thing is deploy a real world working demo at the premises where you predicted, where you want to predict the result, where you want to predict the, where you want to predict the results, predict the solution or solution like something. So this is where you have a real challenge is there. So deploy a real world working demo at the premises where you want to predict the solution. So after you did all this work, you should not stop it that, oh, I have done my work. That's all. My research is done. So it is not something like that. So you need to go for real world prediction. That means in future if something happen, how we can able to do that? How I can able to collect the data sets on those aspects. So that way you can able to predict it. Okay, so one good example here is one example. I'll just take you prawn cultivation. Okay, so let me take a case study here. Again, one example I'll take. Okay, so deploy a real world routing demo. So then create. Finally, I completed. Create a data set for the future. So these are the 12 points that you can able to find a problem statement and you can able to do it. I will give you two options. One is prawn cultivation and fish cultivation versus fish cultivation. Okay. So fish cultivation, generally what they do is fish cultivation needs, the solution is we need use and throw sensors to be thrown in the ocean for the availability of fish, availability of fishes in the deep ocean. Okay, so this is one thing. I'm just telling about the fish in the ocean, sea and the ocean. Okay, so we need to use and throw sensors. That means the sensor will be thrown only once in the water. After that, they cannot take it back because that is where the network deploy. So here we need Internet of Things for this. Internet of Things for this application. So we need IoT for this application. Why IoT is needed is the sensors send the information to the gateway node, which is at the boat or the ship. Okay, so this is where the thing comes. So the deployment application is Internet of Things for this application we want to use. The sensors send the thrown sensors. So I'll use the use and throw sensor. I'll put this way: the use and throw sensors send the information to the gateway node, which is at the boat or the ship. Okay, so this gateway node can send the data to the cloud. So we need cloud computing as well on this. So with the technology is cloud computing as well. So the challenge here is we need use and throw sensors to form a network to tell about the cultivation of the fishes. Okay, so then we have to we have to collect the data. So data means the boat has to be in water for a day, say 24 hours or 24 hours. The challenge here is the fisherman has to carry the boat, and for 24 hours they will be in water. Water means they will be staying in the boat in near the ocean where they deployed the way they thrown the sensors because the use and throw sensors cannot send data if the gateway is far away from them. Hence, the presence of boat at the ocean is mandatory. So this is one challenge. So in that case, they have to go for it. So if needed, the fishermen have to go to the sea or ocean every day for 1 week or so. For 1 week. So this is how the way based on this 1 week they can able to collect the data set. Okay, so in the data set they can able to predict what might happen next. So how many fishes are there? So how many fishes are moving here and there? How many fishes are interacting with it? And sometimes you have to find out whether it is a fish or some other thing. So they need to find out. The challenge here is the challenges are number one is use and throw sensors. Use and throw sensors are costlier. That is one. Number two is not only fishes, but there would be toads, frogs, and other sea creatures might also be there. Okay, so this again we have a challenge here. So not only fishes, but there will be other toads, frogs, and other sea creatures might be there. So number three is presence of the gateway node. Is a challenge. Okay, so this is one challenge. The presence of the gateway node is a challenge. So likewise, when you start doing the project, there will be multiple challenges comes to you, and how we can able to collect all these things. So that way you can just talk to your peer group. Peer group means you can discuss with your friends, say what are the different challenges you might be facing like that. See whatever come across my mind, I'm just writing it here. So in case you might also be having some ideas, so you can also tell me that what are different ideas, so that if it is a discussion, then we'll get multiple challenges. So this is how the way the real world problem can be approached. Okay. So then system specification. So in this case, we need to go for a system specification. So now we need a computer with 8-core CPU and 100-core GPU. 100-core GPU. Okay. So the processing time of okay, so not the processing time. So the data set, the total data set might be suppose we collected the fish data set for 1 second. Every 1 second we collected data. Okay, so let me use it. Okay, so number 7 is data set. Data set, size of data set. Size of the data set. Size of data set. So now what we did is the size of data set, since the boat, the fisherman is already located there. Let's say what we do is Sunday 24 hours. Monday no data. And Tuesday 2 hours. They went to the thing. Wednesday 4 hours. And Thursday 2 hours. Friday again 4 hours. And Saturday 2 hours. 2 hours. Okay. So size of the data set is, so the data collected these days, the data collected by the gateway as per 1 week record. 1 week record. So let's say assuming that the fisherman goes to the sea for 1 week, and Sunday 24 hours they were there. So Monday that wise they didn't go for Monday because 24 hours they extended it. So Monday they didn't go. Assuming that we did for every 1 second the data collected every 1 second. 1 second. Here no data, and for Tuesday every 3 seconds. And here it is every 3 seconds. And here it is every 3 seconds. So all the things are every 3 seconds. Okay, so this way the data is collected. Okay, so now what we do is 2 hours, 24 hours means how you convert into a data set. So 24 means 24 hours divided by 60 minutes. Sorry, 24 into 60 minutes. 1440 minutes into 60 seconds. So that means 86,400. So what happens here is every second means 86,400 records on Sunday. Tuesday it will be 3 seconds. So 2 into 2 hours means 60 minutes. 120 minutes
60.
Divided by 120 minutes into 60 into
Divided by
60
3.
divided by 3. So that means 2,400. So we have 2,400. Here also we have 2,400. So here we have, oh sorry, this is 2 hours means 4,800. 4,800. And this is 2,400. And this is 4,800. And this is 2 hours is 2,400. So now if you see the total data for 9,600, 7,200. So 9,600 plus 7,200. Sorry, 9,600 plus 7,200 plus 86,400 plus 86,400 equal to, so the total size of data set is 1,103,200. So this is the size of the data set. So now just think of already we have a suggestion that whether we can go for a ML model or a DL model. So ML or DL, both are fine. So both are fine for this data set. So now supply these values. So we have almost 1 lakh records for 1 week. Only one day they went for 24 hours. Remaining all the days they either go for 2 hours, 4 hours or something like that. They went for it. And this is how the way the data can be collected. So now the challenge here is the collection of data is the fisherman has to take the boat, go to the near the location where they have thrown the sensors, and they have to collect the record and come back. So this is what the challenge here. But the total record size is 1 lakh records. So up to 1 lakh records we can use ML models, but beyond 1 lakh we can go for a DL model. So here DL and ML both are fine. So ML model also good, and DL model also you can go for handling it. Now this prediction can be evaluated. Okay. Now based on this prediction, you can able to see that on which day the cultivation is more. So whether it's on a Sunday or a Tuesday or a Wednesday, Thursday, Friday, Saturday, that also we can able to predict it. Okay, in case the data is so what you do is 86,400 times you can give Sunday, which day it is recorded. So how you collect the data set, which day it recorded. So for example, in an Excel sheet, when you see that, I will show you one data set also. Okay, so in an Excel sheet, when you say that serial number, then day, so day, then date, then time, then temperature sensor value, then accelerometer x-axis, accelerometer y-axis, then magnetometer x-axis, then magnetometer y-axis, then PIR value. So like this, the sensor value will be there. So serial number day 1 and which is sensor. So we have use and throw sensors. So sensor number. So let's say we thrown 10 sensors. Then serial number 1, sensor number 1, 2, 3, then 1, 2, 4, like that it will be. So days, which day is Sunday. Sunday it is collected, all these things Sunday, or you can use Sunday here. So you can use Sunday here. Then which date you can put, then time, what time you have collected, because 24 hours, right? So the time you can have 1 second everything. So temperature will be something 454. It is an analog to digital converter, analog value only. After that we have to convert it. So in case we have a temperature of 30 degrees Celsius, then 28.7 degrees Celsius, like that. Accelerometer XY, like that. So -1, then 1. So magnetometer. So likewise, the data set will be like this. So this data set, we can able to collect it for 1 week if you have a sensor available with you. Okay. So this is where the prediction can be evaluated. So then you can able to check it how the prediction is appropriate and how the accuracy is analyzed. Analyze the prediction, the accuracy, and the precision. Precision of the record. Okay. So this is where we can able to do a real world societal problem that gives very good information to the fishermen in a particular area where you can really, your help is really, your technology help is really needed for the particular fishermen. So we professors or we scientists, we can able to help them on this particular aspect. So I'll show you one data set, what we have done in some time. I don't remember the date. I'll show you that. So this is my PhD work when I was doing sensor data. Yes. So you can see here. This is the sensor what I deployed in the road. So this is where you can see here. This is the two sensor node. You can see here in the image what I show. It's a box. So in the box here, I have two sensors nodes here. So this sensor node 1 and sensor node 2, and this is a road. Okay. Now I'll show you. Yeah, this is where our campus. So this is VIT Chennai campus. This is one of my student. So what could we do is we identify the vibration of the vehicles whenever a vehicle is moving in the road. So we identify the vibration. And on the other side, we have two more sensors on the other side of the road. One more student also standing there. So what we did is during the month of April, we have tested this. It was heavy hot sun in Chennai, but we asked the students to collect the data. I was sitting in the bus stop with my gateway sensor. I was sitting in the bus stop. I'll just show you whether I know whether there are. And this is how the way the sensor recorded the value. So GW is a gateway. 1, 2, 3, 4. These are the 4 things. So in one temperature is 32.09, in one 30.78, in one 31.92, and other 32.09. So this is how the way the sensor net recorded the values there. Now you can see the values here. So this value you can see. This is the temperature recorder. Okay. So this is the data set what we recorded. So ID is the sensor ID name. Maybe I'll just make it bigger so that you can easily able to find out. Okay. So ID here, sample number is not there. ID means the total I have 4 sensors. The date you can see 2014, 9/4/2014, 10:55. The voltage value, temperature, light, accelerometer x-axis, accelerometer y-axis, magnetometer x-axis, magnetometer y-axis, microphone sound. Then the calculator, the value I calculated, what's the temperature? So using the temperature, I have calculated the reading there. So you can see the number of records. So totally 54,228 records. So 10/4/2015. From 9/4/2015, 10:55 to 10/4/2015, 4:29. So that means almost we have taken for first day morning 10:55 to second day evening 4:30. So that means almost we have taken more than 36 hours. We have taken the record. 36 hours we have taken the record of information. So we have the total record of 54,228 records on this particular sheet. So then we have calculated this these properties. We have done it. So these values we have just calculated them. So this is the data set what we have collected from the sensors. So again, these sensors we have I purchased this through funding. I got the sensors through my one of my funding. So these sensors. So after we got the funding, we did want some evaluation and we have done it. So what we finally thought is we have given the suggestion on relaying the roads, tar roads, how often we can relay the road because of the vibration executed by the vehicles. So whenever any lorry, bus is there moving, the sensor vibrates. So when initially when we place the sensor without a box, vibration was not good enough. So then only we have a box. Above the box, we deploy the sensors. And we try the sensor in the gate of our campus also. But in the gate of the campus, what happens is there is a speed breaker. All the vehicles slow down to less than 20 km/h. In that case also, this sensor does not detect any vibrations. So that's why we have obviously went for a road. Road means there is no speed breaker. It's a state highway. The vehicles will be moving at a higher speed. So we wanted to take that data. So that is how the way we have done this societal problem here. So this we have again done in 2015. Okay. So having said these things, so how do we record temperature? How do we record data? How do we do a societal problem is like this. So now I leave this option to you. If you are from the coastal Andhra Pradesh, then you have an option of prawn cultivation. So you may find out. Actually, one of the work is done by my colleague on prawn cultivation, where she worked on image processing for white patch diseases. She did in one place in Tamil Nadu. There is one place where they do prawn cultivation good. In compared to Bhimavaram, in Tamil Nadu there is one place. They also do well. But when I went to Bhimavaram, it was very big. So there are many places we have a potential for this prawn cultivation. Maybe in case if you want to help your farmers on those things, you can visit their places, ask them the difficulties what they face. So if they need any technological advancement, you can ask them and you can deploy them and can use them. So that way you can able to try it. So prawn cultivation is a small area, but fish cultivation is a bigger area. Okay. So prawn cultivation, you need to fix a sensor device, a water-borne sensor device in a fixed location. So you need not be there for all the times. You can have a gateway also. You can mount it in one side of the prawn field. You can mount it and then go home. You need not stay there. But fish cultivation challenge is the fisherman also has to stay there at a location. So this is the main challenge there. But prawn cultivation is not like that. So the challenges are different. The cultivation also different because they use manual cultivation processing method, and that's a different theme on that. You can able to try those things. So with this, I am just concluding my remarks here. So I have just narrated what are the different applications we can work upon. I have taken a case study of Cloudburst, what we have done it, and I have given you the live the societal application on fish cultivation. And it's up to you now. You can take how you can able to achieve these kind of real world societal applications in your area, in your working environment, or surrounding you. The people, those who surround you, you can help them on the technological advancements, what you acquire and what you study. Thank you. Shri Vishnu College. So in case my thing is Pradeep Kumar TS, my email is email.com. So my areas of interest, you can see my areas of interest: network simulation generally, and IoT and cyber physical systems. So these are my area. So IoT, CPS, NS2, NS3. So these are my areas of research, and of course critical infrastructure system. Critical infrastructure system. So these are my areas of work, and you can always ping me on this email address. So thank you, friends. Now, if you have any queries or any doubts or anything, please feel free to ask.
Sunil sir.
Yeah. So thank you, sir. Sir, thank you so much for giving valuable information. Now I request the participants, if you have any queries, feel free to ask Dr. Pradeep sir. Dr. B. Swati ma'am, you already raised your hand. Please unmute.
Good afternoon, sir.
Yes, ma'am.
My question is, like, you have given us the practical, the things where we can apply the technology in fishing or, the traffic signals or whatever you have shown. But you also asked us to do the application of the same in our local areas to solve the basic problems, right? So what kind of knowledge, what kind of basic knowledge is required for a person to implement all these things, sir? Because these are all technical informations. The common man will not be knowing all these things. So,
Common man, you can ask the common man only the problem what he is facing. Converting that into a technological problem, that we need to do.
Okay, so
Ma'am,
what kind of
actually,
basic
see,
technology you advise?
ma'am, actually, one more work we have done it is, usually my mother usually tell that, see, whenever we have rice prepared in a cooker, we have a cooker, pressure cooker where we prepare rice. So every time when 3 whistles come, it's fine. The rice boiled perfectly fine. But sometimes
True.
when we purchase a new rice of 1 kilogram, we want to test it. So in the
Sure.
third whistle, it becomes so paste. Colloidal shape. The rice
Yeah.
becomes pasty. So my mother usually tell that there is a mechanism saying that automatically when the rice is cooked, the cooker should switch off. The cooker should
Okay.
get switched off. So now, as she said that if this is my problem, if the rice is cooked, let the cooker be switched off automatically. Can you be able to find a solution? So one of my professor tried this. So he deployed one hardware sensor inside the cooker that understands the boiling point of water, that handles the boiling point of water, because boiling point of water is 100 degrees Celsius. So some
Yeah.
hardware circuit that has to withstand 100 degrees Celsius. So he deployed with one heat casing, everything, he deployed it. Using image processing algorithm, once the texture comes, automatically it switches off, but we should use only an electric cooker. Because electric
Okay.
cooker means we can switch off the power directly. But we cannot turn off the stove or something. But the electric cooker, we can disconnect the power supply once there is a signal goes to the power strip. So this kind of problem that we can, but one method is usually, ma'am, actually in VAT, usually what we do is whenever we found a problem, we give the idea to the students.
Okay.
They in turn bring with better ideas. They come with better, sir, we can do this way, like that.
Yeah.
They will come to us.
Yeah.
So
I mean, a
this
lot of
is,
technical information is there, sir. I mean, we can't apply, suppose even we wanted to. So
yes,
that is where I was
ma'am.
just asking, what is the basic knowledge we should have to implement such kind of problems? Thank you, sir.
Thank you, madam. Yes, participants, if you have any queries, please unmute yourself and you can ask. Because sir already given so much information, informative information. Really, it is useful for all, especially the people who are starting their research. Definitely, it will be more helpful, sir. Sir, I hope they are very much clear about the topic. Actually, really, we are thankful to you, sir, for justifying the theme. At the beginning, you mentioned you covered both the topics, that is identifying the real-time societal application. At the same time, you have shown the procedure, how to solve that problem. Really, in the beginning, you started with what are the real-time problems, and you gave some of the examples like assistive transportation and how the augmented reality and the virtual reality, what are the problems with the Pokemon Go game. There you came up with the chatbot based on artificial intelligence, and you came with some example, that is Purvika. You tried to show something on that. There you explained about the challenges when we focus with these problems, how we are going to collecting the data, and how we are going to focus on the big data, and how we need to identify the platforms and the requirements to solve these problems, and what are the basic requirements of these, and where we can get all these data sets, like you gave the areas where we can find like data.gov.in, Kaggle, IEEE data port. So you already mentioned where our data sets are available. At the same time, you gave the statements how we can make our own data sets. You gave the case study of Cloudburst. Nowadays, everyone facing this rain problems. So you are going to predict and calculate. You already applied this in your university with VIT, and how this is you're going to work, and what are the objectives of this cloudburst, and what are the challenges, and while we are finding the data sets, and how you created your own data set with this cloudburst and all. And you mentioned with one real-time example, that is rain gauge, which was already established in your VIT campus, and how this prism data set, how we are going to focus with, and what are the models that we are used for, and you gave what are the real-time problems that we have. Thereafter, you came with the solutions for this, and what are the sequence of steps that we need to follow. That means from starting the identification of the problem, collecting the literature information, challenges that we are facing, and system requirements specifications, identifying as well as CPU, GPU requirements, and where we need to use the machine learning and where we need to use the deep learning. And as of now, we know these two are different two technologies, but we didn't identify for below 1 lakh data set we are using machine learning, more than 1 lakh we are using deep learning.
So it's just
really,
only a sample, sir. It's just only smaller data set, machine learning is fine.
Yes,
but
yes,
bigger
sir, yes,
data
sir.
set, deep learning do that. Yes.
Yes, sir. It is easy for, and you came with accordingly. We came from the Bhimavaram with our respective areas. Majority of the people are focusing on the fish cultivation and prawn cultivation. So you came with that real-time solution for this. How our education as a professors as well as the researchers, how our education will helpful for these farmers. Really, you gave that examples, and what are the steps that we are using and challenges, and how to throw the sensors, and how you collected, as you mentioned, how we can create our own data set. You mentioned with some data of how many hours they go for prawn, the people who fisheries went for fishing, and you calculated with the number of seconds for each hour. So really, we feel that we are also involving in this, and we are also calculated parallelly with you, sir. So what will be the output that we are getting? And really, we are mesmerized with your work, what you did in your PhD, that with you did with your sensors and vibrations, calculating the temperatures with the GW. So really, how you created your own data set, and really, we all are blessed to you have you as our resource person in this series, sir. Really, we the people of the department from Sri Vishnu Engineering College for Bhimavaram, we thank you for sparing your valuable time to share your knowledge and enlighten us, our people, to go forward in their research, and you made our path more easy to reach the destination, sir. Really, thank you so much, sir.
Thank you, sir. Thank you.
Now I request all the participants to enable your cameras so that we will take one group photo. I request all the participants.
Dr. Pradeep Garu, we have started BTech in cybersecurity, sir, this year.
Okay. Okay. Okay, sir.
So I will be in touch with you for regarding some inputs for this also.
Okay, you are from Vishnu College, sir?
Yes, yes. Vishnu.
I have been once, sir, for 3-day workshop. I came there once during which one? Pushpa ma'am invited me for
Yes,
a workshop.
yes. She is from AC. I think
Yes, sir.
she's working in IoT.
Yes, sir. I came here. I stayed there for 3 days in your campus.
Okay, okay. What like in 2014, less than or
Yes.
less than that? And I have received your PPT also, and I will share with the participants, Dr.
Yes, sir,
Pradeep.
yeah.
And I think we have done justice to the title. It seems to be like the theme and the exact content that you have taken are exactly mapping.
Yeah. Yeah. Thank you, sir. Thank you, sir and madam. You can disable your cameras. So on this good evening, we came to the end of this lecture series. So from the Department of CSE, Sri Vishnu Engineering College for Women, first of all, I would like to thank our head of the department, Dr. P. Kiran Sri Garu, and our management of Sri Vishnu Engineering College for Women, and all the participants who made this program grand success with their presence. And I thank, special thanks to Dr. Pradeep sir for sparing his valuable time to share his knowledge to our participants. So really, we are very much thankful to you all for making this program grand success. So thank you one and all.
Dr. Pradeep, thank you very much, and have a nice day, sir.
Yes, thank you, sir. Thank you.
I will get back to
Thank
you.
you.
I will get back to you.
Okay, sir.
Thank you, sir.
Thank you.
Dear participants, we will share the feedback link in WhatsApp group. Please fill it.